Yo, hey everyone. Another workshop, another week, starting at the first ever Cosmos Hackathon in Russian, HackAtom RU. Happy to see you there again. Thanks for tuning in. Today, a super useful workshop is in store for you from the Secret Network guys. I hope that you'll be watching attentively, carefully. You'll have multiple questions and our speakers can take them after the question. Now for the Q&A session, how to submit your questions. If you're on YouTube, you can see the chat there. You can use it. You can ask the questions directly, typing into there. English, Russian, whatever, just type into whichever language you're comfortable with. Also, the Telegram, now the pop-up, our hackers Telegram chat. Feel free to ask questions in there as well. I'll be watching, I'll be monitoring, and at the end, I'll relay your questions to Asaf and the other guys, and maybe hopefully somebody, someone of them will come up with the answer. Hey guys, ready to start?
Yes.
Let's make a brief sound check.
Yeah, hello guys.
You can hear us.
Happy to be here.
Hi guys.
Hello.
Отлично, кажется. Супер, кажется, всех слышно, всех видно. Мы можем начинать. Я передаю
Awesome.
слово.
We can hear and see everyone. The floor is yours, guys.
Thank you. Hello everyone. So today I'm going to talk about the secret network. We'll start with a few slides just to make sure everyone in line, and then we're going to go over some code, and then we'll take some questions. So hello, I'm Asaf, and here with me are Ruben and Tom. We are all blockchain engineers at Enigma MPC, and we build Secret Network, which is the first ever layer 1 blockchain with encrypted smart contracts. First and only. And we are already live for over 6 months now. So let's see what Secret Network is all about. So Secret Network is a blockchain that lets anyone perform computations on encrypted data, bringing privacy to smart contracts and public blockchains. Think like Ethereum, but with encrypted smart contracts. So as we already said, Secret Network is the first layer 1 blockchain with private, smart, or secret contracts. And it's a Cosmos-based blockchain, which means correctness is guaranteed by Tendermint consensus. Native coin of Secret Network is SCRT, or secret, which is used for staking, governance, and gas fees. And secret contracts are based on COSM. They are written in Rust and compiled to WebAssembly. And what's special about them is that contracts have encrypted inputs, state, and outputs by default. So how it works, a user sends encrypted input as a transaction to the blockchain. Then all nodes perform the computations needed to calculate the output of the contract inside a trusted execution environment. And if the contract stores state, then the state is encrypted, and it's stored on the public blockchain, but is encrypted, and only the contract can decrypt it on its own state. And then if there's also an output to the execution, only the sending user can decrypt the output. So why you should build on Secret Network? We have privacy tokens, which means you can send and receive tokens privately. So balances are private, and sending and receiving funds is private. This is already live on mainnet. We have an Ethereum bridge, which means you can transfer ERC assets to Secret Network. This is also live. And we have Secret Swap, which is an AMM. You can swap assets on Secret Network. Coming soon are private NFTs. You can own unique digital items, and it's private. And lending applications, you will be able to borrow assets with or without collateral. All of these are great building blocks to build more complex DeFi applications. Also, on Secret Network, you can build applications that were not possible until now. You can use random numbers, for example, for games, so poker, blackjack, craps, roulette, whatever. You can store private state in your contracts. So for privacy tokens, for example, balances are private, and also transferring funds are private. And for example, for card games, you can have private hand. This is not possible if the state is not private. You can see everyone else's hands, and you can't play that way. Because inputs are encrypted, you can build front-running resistant DeFi apps. The mempool is encrypted, so attackers can't front-run your transactions. And much more, the sky is the limit, at least. And these are links and stuff. I'll send it at the end as well. And now I want to show you guys a simple dice game. So we're going to go over a secret contract which implements a dice game. So the rules will be, there are 2 players. The first player joins in, and then the second player joins in, and once both players are in, the contract can roll a dice and decide, and the winner will be, if the dice result is between 1 and 3, then player 1 wins, and if the dice roll is between 4 and 6, then player 2 wins. And we're going to see this in a bit, how it is possible on Secret Network and not every other network. So like we said, secret contracts are based on Cosmosm. If you're familiar with it, they are written in Rust and compiled to WebAssembly. And Rust has a reputation of a language that's hard to learn, but for writing secret contracts, you really don't have to know much Rust to begin with. It's a more simpler version of Rust. So this is the main file, the contract. So let's see what we have. We want to store a state in the contract, which is private by default. So we have a player 1 address and a secret that the first player will send when he joins. And then player's 2 address and the secret that player 2 will send when he joins. And then after both player joins, we are going to save the result of the dice roll and decide on a winner. So this is our entire state for the application. These functions make sure to store the state in the contract storage. And now let's see the init section of the contract, which is the constructor of the contract. So when you deploy a new contract, you have to send an init message to the init function. So this is just an empty message. We don't need any data when we instantiate the contract. And when the constructor is called, we just initialize an empty state. As you can see, everything is empty, and then we save it to storage and return a success response. So, and now the handle section or the execute section, this is the main section of the contract. This is where all the logic of the application or the game will be in. So this contract supports two types of messages or execution modes. A player can join the contract and his secret, and the player can leave the first player can leave the contract if he waits too long for player 2 to join. So let's see how we implemented this. So when a user sends execute transaction, which we check if it's a join transaction, and this is the input secret that the player sends. So let's go over what we are going to do here. So player 1 joins, and they say they send a secret number, this, and deposit 1 SCRT to the contract. And then we are going to store the secret privately in the contract storage. Then after a while, player 2 joins, and he also sends a secret number and also deposits 1 STRT to the contract. And we are also going to store the secret that player 2 sent. Once player 2 joins, we are going to derive the share secret, from the secrets that both players have. And because this is a competitive game, then no one knows what player 2 can't know the secret of player 1, and player 1 can't know the secret of player 2. So if we are going to use both numbers to derive a secret, no player will know the shared secret. And then we can use the shared secret to roll the dice and choose a winner. Then if the dice roll is between 1 and 3, player 1 is the winner, and if the dice roll is between 4 and 6, player 2 is the winner. And the winner gets the 2 SRT that were deposited to the contract. So let's see how we implement it. So first thing, we are going to check that whoever joined the game deposited 1 STRP. So this is how we do it. We go to the handle variable that is available in every handle function, and we check that the amount that was sent is 1 million U secret, which is 1 secret, and the coin denomination is U secret. And if not, we return an error. The user gets an error, and the entire transaction is reverted. Okay, so if we're here, this means that the user deposited 1 SCRT to the contract. Now we are going to load the state, the encrypted state, which is, if this is player 1, the state is just initialized to be empty first. So now we're going to check in the state if player 1 is none or isn't set. So this means that this is the first player to join, and we are going to set player 1 to the message sender or transaction sender. And we are going to save the secret that the first player sent. And then we are going to store the state in the storage of the contract. And as a reminder, the state is encrypted, and only the contract can load it and decrypt it. So now when the player 2 joins, he doesn't know the secret of the player 1 sent. So if we are here, this means that player 1 is already set and player 2 is not set. So we are going to set player 2 to be the message sender or the transaction sender of this invocation, and we are going to store the secret that player 2 sent. And now we have all the pieces to derive a shared secret. So we are going to take the secret of player 1 and convert it to a vector of bytes. And then we are going to take the secret of player 2 and convert it to a vector of bytes. And we are going to push it to append it to the combined secret. So now in the combined secret vector, we have player 1 secret and player 2 secret appended to each other. And we are going to take this combined secret and use it as a seed to a random number generator. So we are going to hash it to be 32 bytes or 256 bits. And then we are going to see the random number generator with this. And then to determine the dice result, we are just going to get the next random number and make sure it's between 1 and 6. And then we are going to choose a winner. So if the dice result is between 1 and 3, the winner is player 1. Otherwise, the winner is player 2. And then we are going to store the state with the winner and player 2. And the output of this transaction is going to be a transfer of 2 SCRTs to the winner right away. So this is the main logic of the game. And now let's see what happens if player 1 joined in and player 2 isn't in yet, and player 1 wants to leave the game because maybe he waited too long, or maybe he needs his money back. It's just a way to allow the player 1 to withdraw its deposit before the game begins. So we are going to load the state, which is encrypted in the storage. And then we are going to check whether the transaction sender is player 1. If not, we are going to return an error. Next thing we are going to check if there's already a winner. If the game is over, player 1 can't get his money back. And we're going to return an error. If we're here, this means that only player 1 is in the game and still waiting for player 2. So we are going to update the state to delete player 1 and also delete the secret. And we are going to store the new state. So now the game is open for 2 players to join. And the output of this leave transaction is going to be, we are going to return 1 SCRT to the transaction sender, which is player 1. And that's it. That's the main, that's the entire logic of this game. Now, because everything is encrypted by default, as a secret contract developer, you can choose what is public and what is not. So, how to reveal private data? You implement a query. Queries are not transactions; they happen outside of transactions. And let's see how we implement a query that just returns the results. So if someone asks, give me the results, we are going to load the state and check if one of the players is not set yet, then we're going to return an error. We can't return the result. And if both players are set, this means that there's a winner, and we are going to return this is the winner, this is the address of the winner, and this is the result of the dice. And that's it. 200 lines, and that's it. And this is just an example of a contract that uses random numbers and also utilizes private state and also private inputs, secret inputs, and they are private. We can take questions now if there are any. If there are not, I can also show you guys how the Ethereum bridge looks like, and how the AMM looks like. Are there any questions, Mariam?
No, seems like we don't have questions. У нас нет вопросов сейчас.
Doesn't seem that way.
Можем переходить к мосту с эфиром как раз.
We can go to Ethereum bridge. By the way, yesterday one guy asked a question about that.
What was the question?
Я сейчас не вспомню, но что-то.
I cannot remember it exactly, but there was something about Ethermint, how to build. Well, I need to go to YouTube to recall this question if you want.
Okay.
That's the previous video. There was something about Ethermint, something about bridging. Well, just go ahead talking about the bridge, and then we'll sort this out.
Okay, let's go over to the bridge and see what's going on there. Bridge. Oh. Okay, so I don't have Kepler installed. I don't have MetaMask installed, but let's see what's going on. So the bridge allows users to transfer ERC20 assets between Ethereum and Secret Network or Ethereum itself. Let me just set up Kepler very quick. So never mind. If a user wants to transfer Ethereum to Secret Network, just a second. Sorry. I can't install the wallet on this machine, but I'll just go over it without wallets. So users can transfer Ethereum to secret network, and they are going to get secret assets. And also, they can transfer all of these assets to secret network. And as contract builders, you can use these assets in your contracts. Right now, users can deposit assets in some of our contracts and receive reward. So you can see on Ethereum, there's 65 annual percentage yield, which is pretty nice. And there are $36 million locked in this contract. And I suggest you go over to Bridge Network and see what you can do there. But right now, users can deposit their secret assets and earn rewards. And they can also go to Secret Swap and swap between tokens. So I can swap STRT to STTI, for example, or to Ethereum. And this is also available to contracts. So as a contract, you can use this swap contract to swap assets for your user. I don't really have much to say. Tom or Woven, did I forget something?
I mean, we can explain a bit about how the bridge itself works, how you can convert assets to secret assets and how they work.
You want to go for it?
Yeah, sure. So Asaf will be my Asaf will be showing what I'm explaining. So again, Secret Network is a fully fledged layer 1 network that's independent to Ethereum. But we do allow people to basically convert their Ethereum assets into secret versions of those assets, which allow secret transactions, have secret balances, and all that fun stuff, and can be used on our other applications. So what this bridge allows, what you can see here, is sending tokens either from Ethereum to Secret Network or back from Secret Network to Ethereum. In order to use it, you'll have to install both MetaMask and Kepler. Kepler being a wallet in the Cosmos ecosystem. And then on the left side of the screen, as you can see, you can select a token that you, Asaf, if you can click the select your token button. Thank you. You can see you can just choose whichever asset you want to convert to a secret asset. Once you choose it, you can choose how much of it you want, say secret band. You would send some amount. The transaction usually takes a few seconds to like a couple minutes to process, depending on Ethereum block times, Ethereum traffic, that kind of stuff. And once you have that converted, we can't really show you right now because the stuff doesn't have Kepler installed. You will have to create a viewing key in order to be able to see your balance. It will be on the right side of the screen. You'll have to create a viewing key for every asset that you've converted. So for example, we've converted band to secret band. We'll have to create a viewing key in the UI for secret band. Maybe I can share my screen. Maybe that'll be useful. So I can actually show people what I'm talking about. Let's look. Let me open the bridge. Why is this not working? There we go. Yeah, so once you have that viewing key set up, you will be able to see your balance, but no one else will be able to see your balance. And all the other functions on the bridge basically work with those secret assets. Now, once you've converted your assets to secret assets, you can go back from secret to Ethereum. You'll see that on the secret to ETH tab over there. Asaf, can you click secret to ETH? Scroll down. Yeah, and you can see the UI is very similar. You just convert from your secret band tokens. You choose some amount and to which address you want it on Ethereum, and just go ahead with the transaction. Again, it'll take a few seconds to a minute to a few minutes to process. And the nice thing is you can send it back to any address that you want, right? And say you want to disconnect to Ethereum addresses, right? You can send your funds to the secret network. You can shuffle it around privately between a few secret addresses, send your funds back, and all your transactions are public from that. Like, sorry, your the connection between your various Ethereum addresses becomes private at that point. And now if I can just load the bridge, because my computer is overloading from Zoom, I'll close a few windows. I'll be able to show you what I was talking about with the secret tokens.
Asaf, if you could stop your sharing.
Yes, exit. Excuse this. It takes just a minute. I'm like out of RAM right now because of Zoom. Oh, here we go. Okay. Aha.
Share screen.
Please hold. I'm just setting stuff up so you don't see my passwords. All right. I'll share my screen now. I hope that will show on the. Nadia, can you please allow me to share my screen? Or wait, you can just.
Yes, yeah.
No, you do have the rights.
Включаем, я просто напомню.
So, as you're in process of sharing your screen, I'll just explain briefly. Yeah, finally, the screen is coming up. Perfect.
Cool.
Anyway, questions time. Please feel free to type any question you have to the speakers into the chat boxes. The floor is yours again.
Cool. So, as you can see here, this is the bridge where both wallets are connected. You can see I have some Ethereum here. This is a test Ethereum. That's not Ethereum, but still. And I have some SCRT here. And for example, if I was going to convert from Ethereum to secret Ethereum, you see it doesn't show me my balance by default. It asks me to create a viewing key for secret Ethereum. If I was going to use some other Ethereum-based token, for example, we were using Band before, right? So refresh this for a sec. There we go. Okay, seems to not be working right now. Let's try another asset. Okay, never mind. Seems to be an issue currently. Anyway, so say I was gonna be using Ethereum. By default, it doesn't show me my Ethereum balance. If I click View Balance, I have to send a transaction to the secret contract. As you remember, we choose what to show and what not to show. So viewing our balances is done via queries. So by default, a query doesn't have the concept of a querier, right? Queries aren't signed in any way. The contract has no way of knowing who's querying it. So using a transaction, we create an association between my account and some password, some API key, which we're going to be doing here. I'm just going to submit this transaction, where you can see here it creates a viewing key. I'm going to approve this. It's going to take a minute. Once this association is made, this viewing key is saved in my Kepler wallet extension. And in a few seconds, I'll query it again, and we'll be able to see that now only I am able to, with my password, to see how much secret Ethereum I have. Try to refresh the page. It might be a bit slow right now. And here we go. You can now see my balance. I don't have any secret Ethereum converted yet. And the nice thing is again, only I'm able to see how much I've transferred or how much I have in my account. If I'll be able to move this, here we go. Up here, if I open my Kepler extension and I go to secret network, right, I can see here all the tokens for which I have viewing keys. And I can come inside here. I can choose some recipient, how much of the secret token I want to send. I choose my fee, right? And all these details are private. The only thing you can see on the network is that I've interacted with the secret Ethereum contract, but you can't know who I sent funds to, how much I sent them. You can't see any connection between the things. And only they can, in their transaction history, find that I have sent them some funds. And again, I don't have secret Ethereum, so I'm not gonna go ahead with this transaction. And that's it. I don't know, Asaf, is there anything else we'd want to show them here? Again, if there are any questions.
I think we are going to stay in the chat to answer questions. If there are any, maybe later.
All right.
I think we're done.
Easy enough.
Отлично. Тогда давайте будем ждать.
Great, guys. So let's keep looking forward for the questions. They might be coming up soon. I see you guys. Edit yourself there. So if anybody views this workshop, which is things that have happened before, so I will relay the questions if they come your way. Thank you so much for doing this workshop. Any addition, any summary before you go?
That's it for now. Again, if people have any questions, feel free to ask us in the Telegram chat. You can also find us on chat.scrt.network. It will send you to our Discord server where you can talk to us freely. We're active there all the time, and we'd love to see you there.
Спасибо. Спасибо большое за контакты.
Thank you. Thank you for sharing the content. Thank you. Thank you again for doing this. And you guys, the listeners, 7 p.m. Moscow time, feel free to drop by for another workshop, participate, engage, get engaged, and ask questions. Tomorrow we have the final workshop. All the workshops that are happening are stored, recorded on Cyber Academy and Cosmos on YouTube channels. So as the hackathon is in progress, the speakers will be available to have your questions if you have some afterwards. I will see you in the evening.